All right. Hello, hello, hello. So today we're going to be talking about electron pairing rules. This says bonding rules. This should say electron pairing rules. I just didn't realize it until like this second as I hit record. So electron pairing rules is what we're going to talk about today. Okay, so I'm going to step off screen, let you guys pause and write all this stuff down. And I would just write everything that's on the board right now. And then I'm going to draw a diagram to kind of go with this stuff to explain some kind of the differences between them. So, yeah. All right. And I'm going to assume you paused. Okay. So there are three kinds of electrons that you're going to see in, well, and I should actually go a little more specific. There are lots of different kinds of electrons. We're talking specifically about valence electrons. Okay, valence electrons have rules that govern how they behave. We introduced a few of these when we talked about Lewis structures. Okay, and we're going to go back to Lewis structures for this. So first off, there are three kinds of valence electrons. Electrons that are already paired up, these are called lone pairs. Electrons that are by themselves. These first two are the only two kind that can exist within a single atom. One atom can only have these two kinds. So, for example, I need to prep something. One sec. All right. No. All right. So we're going to use oxygen as an example because it's a pretty good example to roll with. So I'm going to draw a dot diagram for oxygen. So oxygen has 6 valence electrons. It has to have 2 that are paired up and 2 that are by themselves. So if we were doing our dot diagram, we'd have to put 1 on each side. And then the last 2 would have to pair up. So I'm going to pair here and here for reasons we're not going to worry about yet. Okay, so we have here a couple of different kinds of electrons. These ones here are your lone pairs. Okay, they are electrons in the valence shell that are already paired up. Okay, so these are your lone pairs. Okay, and then we also have unbonded electrons, which are the electrons that are by themselves. Okay, these are the electrons that are basically, they're single. Okay, they don't have a partner. Okay, they're on their own. Okay, the third kind of electron, I need to make this big again for this. If oxygen floats along and it finds a hydrogen atom, that hydrogen atom is going to have 1 valence electron. Well, both of these electrons are unpaired electrons. And the thing about unpaired electrons, so no calling out names on this. How many of you can think of that one friend that you've got that just can't be single? They have to be dating somebody. They break up today, tomorrow they're dating somebody new. That person. Okay, that's how unpaired electrons are. They have to be dating somebody. Okay, and reactions, chemical reactions, are all about getting these guys to break up and then go out with somebody new, basically. Okay, so a bond pair is when 2 unbonded electrons actually form a bond. What? Oh, you've got to be kidding me. Okay, so I know for you it's been like half a second, but for me it's been a minute or two. On these bond pairs, the third kind here, you can't see those in individual atoms. They exist between 2 atoms. Okay. Oh, hey, I didn't turn my pen back on. Hang on. Okay. Okay, so a bond pair is going to be a pair of electrons where each electron comes from a different atom. Okay, it's these single electrons that have gone out and found a buddy or someone that they can go out with and they can hang out with. Okay, lone pairs cannot form bonds. Okay, these are your old married couples. They don't cheat on each other. They can't go out and make any bonds. Okay, they're together. They're happy. They're satisfied. They're not going out and looking for anybody. Okay, unbonded electrons are constantly on the prowl. They're always looking for somebody. However, each atom, okay, this is a family. You can't date your sister. Okay, you can't date your brother. Okay, these two, they can't form a bond pair because they're in the same family. Bond pair has to be between an electron from this family and an electron from a different family. Okay, it might both be oxygens, okay, but they're not going to be in the same atom. They're going to be in different families, okay? So the electrons that are already paired up within the dot diagram, these are lone pairs, okay? These cannot form bonds. The electrons in an atom that are by themselves, these are unbonded electrons. These are the ones that can form bonds. They're out looking, trying to find somebody. And then the ones that have got the circle around them, these are bond pairs. Okay, these are electrons that are dating someone for now. This might last for a long time. It might last for a couple of minutes, and then they might move on. Who knows? They're pretty capricious. Okay. So yeah, that's pretty much it for this. This is a pretty short set of notes. That's why we're doing it today. So yeah, that's it. I'm going to sign off here. Have a wonderful whatever it is, and I will see y'all next time.